We're going to start with a brief preview of what calculus is and how it ties to pre-calculus. Now, when you were in pre-calculus, you studied quite a number of things. You studied functions. You should have become quite proficient with the unit circle. You should have studied the trig identities. You should have done quite a bit of algebraic manipulation. Algebra is your friend. G-E-B-R-A. Having trouble spelling here. At the end of the year, you should have done some limits. Do you remember this was the limit as x approaches some value of f of x? So, now, we're going to start our class right there, okay? We're going to start with limits, and then we're going to branch off and do some really cool and exciting things. You had no idea where you were starting when you finished up last year. Now there's a bunch of things. I can show you several slides of different things you can do with and without differential calculus, and then with and without integral calculus. This will be the second half of the class. The differential is the first. Now, one of the first things you needed to do in calculus or in pre-cal was you did tangent lines. Now, it was easy to find slopes of lines. You knew the slope was rise over run, and you would have no problem rewriting this. And this here is your delta y, and there's your delta x. We are going to do quite a bit of manipulating and then doing limits. With calculus, we take these points and we bring them down. We take these secant lines and we take the limit as our secant lines approach the tangent line. And that's really a lot of fun. In integral calculus, you could find areas, but you couldn't find funky areas. You could approximate these, You could find the area of one rectangle and the area of the second rectangle and the area of the third and the area of the fourth, and here we have 8. But if you were to add these up, this would give you an approximate area because, of course, they're not exact. You can see that this would actually be, my tablet sideways, this would be an underestimate because you have all of these parts right here that aren't accounted for. And if we take the rectangles and make them smaller, then we do get a better approximation. As a matter of fact, that's what we'll be doing in the second half of class. With calculus, we can find this area exactly. There is no approximation to it. Now, in pre-calculus, you analyze piecewise functions, and you're going to need to be able to do that with ease in calculus. And we will have other methods of finding what this curve looks like. I mean, we can sketch this fairly quickly. Let's see, we have, it's defined x 1, 2, 3, 4. When x is greater than 4, this is equal to 4. So this piecewise function, all right, let me switch pen color for the middle part, or for the end part, it's equal to x squared when x is less than or equal to 2. So x squared, let's see, 2 squared is 4, all right. And what does x squared look like? Well, it goes here, and it's symmetrical. So I'll come over here, and you will do a much better job. I'm just rushing through this. Let's see. It's hard to draw these backwards. All right. Now, do we see we connected this endpoint, and then we had this endpoint. So this curve right here will have an open to show that those 2 points aren't part of this part of the curve. Now, at x equal, let me switch pen colors again. At x equal 2, I have 8 minus 4, which is 4. So this is at x equal 2. So I'm going to come up here at 2. Okay, I'm going to put a circle here, open. And then at x equal 4, this is equal to what? 8 minus 2 times 4 is 8. Oh, this is 0. Okay, so it's going to be down here. And we recognize it's a straight line, and you'll get out your handy-dandy ruler, which I don't have, and you will draw a much better line than I do. So you will be able to, you should be able to do these, and very straightforward and much more neatly than I just did. Another thing you did was you found limits. When you did limits, you would, for example, take this and do this as we're going to do this numerically and graphically. This is what the graph looks like, but you would actually just plug the numbers in. So this would be 3.9 divided by 3.9 plus 1 minus 4/5 divided by 3.9 minus 4, and that gives you a number that is equal to, let's see, 0.0408163. And we will do these in class to where you find these, and then we can see what number as they get closer from the right and from the left. What number is my function approximating? Now, we will be able to analyze these types of functions where you have all sorts of jumps and discontinuities and asymptotes going on.